Alright guys, so in today's video we're going to be starting chapter 3, and in this chapter our main focus is going to be on the variety of ways that we have to graph lines. So we're going to start with some basic vocab so that when I'm talking about things as we're going through the rest of the chapter we're all on the same page. So here we go. The first vocabulary word is x-axis. So when you look at a graph, it's going to look like this. There's going to be this dark vertical line with arrows on it and this darker horizontal line with arrows on it, and those are both called axes or axes. The x-axis is the horizontal axis on the graph. It goes this way. So this right here would be the x-axis. Now, the y-axis is the vertical axis on the graph. So it's going to go up and down, which in this picture would be this line right here. Once you've highlighted or kind of seen those two axes, you'll realize that when you do that, you divide the graph up into 4 sections. There's a section on the upper right, upper left, lower right. Each of those sections is called a quadrant. So we number those to make it easier to talk about them, and we start with the quadrant in the upper right, which we number 1. Quadrant number 2 would be the upper left. Quadrant number 3 would be the lower left. And quadrant number 4 would be the lower right. Now we usually use Roman numerals for those. I don't really know why, just kind of is what it is. And if you look at the order they go in, they just sort of go counterclockwise in a circle around the graph. Last but not least, we're going to talk about the origin. The origin is the point 0, 0 on the graph. It is where the two axes intersect. So this specific point right here on the graph is the origin. And we start all of our counting when we're graphing points by starting there and counting either left, right, up, or down from there. Now, speaking of graphing points, we're going to be doing a lot of graphing points. So let's just kind of review how that happens. When you see a point or an ordered pair, it always has 2 parts. The first part is what's called the x-coordinate, and it's always the first number. Now, the x-coordinate tells us to move left or right from the origin when we are graphing. The second number, so the second coordinate in the ordered pair, is what's called the y-coordinate. And the y-coordinate moves us up or down after we've gone left or right, so from wherever we end up. So let's practice graphing. If we want to graph the point -2, 4, -2 says, starting at the origin, go left 2 spaces. And the reason we go left is because it's negative. The +4 says, okay, from there, go up 4 spaces, and the reason we go up is because that's a positive, and that would put our final point, where we actually put a dot, right here on the graph. So let's practice some problems where we kind of just review and use all of these vocabulary words and this new information. The first thing we're going to practice is writing an ordered pair that corresponds to a point. So if I want to write the ordered pair for point A, for point A, I would start by putting parentheses because parentheses are really important for ordered pairs. Now to get to point A from the origin, first I would have to go right 3 spaces. So my first number would be 3, and then I would have to go down 2 spaces. So my second number would be -2. The parentheses here are really important because that's what tells us this is a special pair of numbers, not just a random list. So if you don't have those parentheses, you do lose points when you list these ordered pairs. Now to get to point B, again I need parentheses. I would go left 2 spaces, so I would make this a -2, and then up 1 space, so I would make this a +1. Then for point C, and I'm not going to draw this in on the graph this time, again I need a parentheses. From the origin, because C is directly above there, I'm not going to go left or right any spaces. So my first number would be 0, and my second number would be +2, because after I don't go left or right, I just go up 2. And for point D, I would need to go, to get to point D, left 3 spaces, so -3, and then up 4 spaces, so +4. Now let's see if we can go the other direction. So if I give you an ordered pair, can you graph it and then also list the quadrant that it's located in? Let's start with point A. To graph point A, first I would start at the origin and go left 4 spaces. Then I would go up 4 spaces. Now it's very important that you label which one's which. So this is point A. And if I think about my quadrants, this would be quadrant number 2. So I would just put a Roman numeral 2 there. Next, we're going to do point B. So from the origin, I would go right 3 spaces and then down 2. And this would be point B. This would be quadrant 1, 2, 3, 4. So I put a Roman numeral 4 here. And point C, since the first number is a 0, I wouldn't go left or right. The second number is -4, so I would just go down 4. I would label that point C, and my quadrant doesn't really exist. It's kind of like on the line between 2 quadrants. So what I would do for that one is just write y-axis. Now, if it was on the other line, so it was kind of in between 2 quadrants the other way, I would just write x-axis. Now let's take a look at how we use graphing points to graph lines. So the first way we're going to learn how to graph a line is by making a table. Now when we want to do this, there are a couple steps to this process. The first step is to rearrange the equation so that the y is by itself. All of your equations are going to have x's and y's in them. You're going to want y to be by itself. Then you're going to make a table of ordered pairs, or in other words, of points that you're going to graph. And then lastly, you're going to actually graph those ordered pairs, and they should make a line. If you graph them and they don't all line up perfectly, you're going to want to go back and check your work because you definitely should have them make a straight line. Now for this part of the lesson, you're going to need some sort of a straight edge. So your ID is a great choice because it's got a straight edge on it. Or if you have a protractor or a ruler, you could use that as well. But you need something with a straight edge on it. Let's take a look at number 1. Step 1 is always to rearrange the equation so that y is by itself. But if I look at number 1 here, the y is already by itself. So that step is kind of already done. Now we're going to make a table of ordered pairs. So we're going to write x and y, and we're going to have 2 columns in our table. Now for our x values, we want to choose a variety of numbers. We can choose whatever numbers we want to put there. So I usually choose -2, -1, 0, 1, and 2. Now in order to figure out the y values, we can't just choose. What we're going to have to do is we're going to have to plug in those x's to the original equation and calculate the y's. So my first y would be, and again, I'm using this equation and I'm just taking this x and plugging it in. So I would have 2 times, instead of the x, I would have -2 minus 3. If you would like to use a calculator to do that computation, you can. The answer is -7. Do the same thing with -1. So my y will equal 2 times, and instead of x, I'm going to plug in -1 minus 3, which is -5. Again, you can use a calculator to help with that computation if you would like. If I plug in 0, I would have y equals 2 times 0 minus 3, which is -3. If I plug in 1, I would have y equals 2 times 1 minus 3, which is -1. And if I plug in 2, I would have y equals 2 times 2 minus 3, which is +1. Now, once I have all of those numbers listed, I've got all of these ordered pairs written down. What I'm going to do next is I'm going to graph these one at a time. So here's what I mean by that. The ordered pairs that I just made are the point -2, -7, -1, -5, 0, -3, 1, -1, and 2, 1. I just figured out x's and y's that go together. So if I graph that, -2, -7, starting at the origin, I would go left 2, down 7. Now this graph only goes down to -6. So I would just go down approximately one more space and put a point there. You don't have to do that. If your points are ever over the edge of the graph like that, feel free to just not graph those specific numbers and skip to the next one. So we would go left 1, down 5 for the next one. For the next one would be 0, -3. So over 0, down 3. Then 1, -1. So over 1, down 1. Then 2, 1. So over 2, up 1. You'll notice that if you kind of look at the graph, all of the points are lining up and making a nice straight line. So all we're going to do next is connect the dots. Now when you do this, I'm going to be very specific about what I want you to do. I want you to use a straight edge. I want you to draw your line so that it extends beyond the edges of the graph. I didn't just stop when the grid stopped. And I want you to put arrows on both sides. It's very important that your lines represent that they would continue forever and ever and ever. That's what a line does. If we wanted to, we could make this table go on forever and ever and ever and keep adding numbers. The line represents all of those ordered pairs without us having to make a super long list. It just shows us visually what ordered pairs we have instead of having to calculate them with numbers. Now that's a pretty straightforward example. Let's take a look at number 2. Number 2 is a little bit more complicated because in number 2, the y is not already by itself. So we're going to use the same idea as we did in chapter 2. And we're going to rearrange this equation so that y is by itself. If I want to get y by itself, I'm going to start by adding x on both sides. Now when I do that, I get 2y equals +x minus 3. Then I'm going to divide everybody by 2. So I would get y equals, now the invisible number by the x is a 1, so it would be 1/2 x minus 3 over 2. Now we're going to make a list of ordered pairs. So x and y. Now the x's, I usually always just pick -2, -1, 0, 1, and 2. And again, I'm just plugging these in. So let me show you on my calculator what's happening here. I'm going to take a -2 and I'm going to plug it in instead of the x. So I'm going to type in alpha y equals 1/2 parentheses -2 minus alpha y equals 3 over 2. And when I do that, I get -5 over 2. Or if you want to know what that is as a decimal, you can just type in -5 divided by 2. and you get negative 2.5. I often find it easier to graph when I have decimals versus when I have fractions. So you'll notice that I turn a lot of my graphing answers into decimals. All right, now I'm going to type in negative 1. So alpha y equals 1/2, parentheses negative 1, minus alpha y equals 3/2, which is negative 2. I'm going to type in 0. So if I hit up, up, up with my arrows and I hit enter, it'll actually copy this down. And then I can just kind of backspace and replace the negative 1 with a 0. And again, if I turn that into a decimal, negative 3 divided by 2 is negative 1.5. If I hit up, up, up till I highlight it and I hit enter, I can change the 0 to a 1. And then I get negative 1. And if I hit up, up, enter, I can change the 0 to a 2. I'm sorry, the 1 to a 2. And negative 1 divided by 2 would be negative 0.5. So I'm just plugging in my numbers into the equation. Now I'm going to graph this. So I'm going to go left 2 spaces, down 2 and a half. So I'm going to be halfway in between those two lines. Now I'm going to go left 1, down 2, over 0, down 1.5, over 1, down 1, over 2, down 1/2. Now you'll notice all my points are lining up nicely again. I'm just going to take my straight edge. I'm going to make sure my line goes beyond the edges of the grid. And I'm going to put arrows on both sides. Let's take a look at another special kind of line. Let's say I gave you the equation y equals negative 2. So if I said make a table, first, y is already by itself. I would make a table. I can pick whatever x's I want. Negative 2, negative 1, 0, 1, 2. However, the equation just says y is equal to negative 2. There are no x's. There's no place to plug in my x's. And what that basically just means is that all of the y's in the table should be negative 2's. So if I were to graph those points, I would do left 2, down 2, left 1, down 2, 0, down 2, 1, down 2, 2, down 2. All of my points are lining up. They're making a line, but it's a weird line. It's perfectly horizontal. So that's a little different. If I were to make a similar table, but for the fourth equation here, it says in the equation x is negative 1. And what that means is that all of the x's in your table need to be negative 1's. But the y's could be whatever they want. There is no y in this problem. So I could make it negative 2, negative 1, 0, 1. Doesn't matter. If I were to graph those, I would have negative 1, negative 2, negative 1, negative 1, negative 1, 0, negative 1, 1. So all of my points are lining up. It's just that they're making a perfectly vertical line, which is a little bit weird. So what the heck is going on here? Well, we call these special lines, and we have a special word to help us remember how to graph these so that we don't have to make a table like this every time. When you see an equation with only one variable, so for example, problem number 3 only had a y, and problem number 4 only had an x, we use an acronym, which means it's like letters that have special meanings, to help us remember how to graph them. So it's actually 2 special words. Vux, hoi. That sounds kind of silly. It's made up, but it does help you remember. The V in Vux stands for vertical lines. The U stands for undefined slope. And we'll learn why that's important in a later part of this chapter. And the X stands for x equals in the equation. So whenever you see an equation that has an x equals, you know it's going to be a vertical line automatically. The H in hoi stands for horizontal lines. The O stands for zero slope, which will be important later on in this chapter. And the y stands for y equals in the equation. So whenever you see an equation that just has a y, that's going to be a perfectly vertical line. So let me show you an example. In problem number 5, we have y equals negative 2.5. So we're going to think about the magic word hoy. If our equation only has a y, then that means it's going to be a perfectly horizontal line. And it's going to be located where the y value is negative 2.5. So on the y-axis, I'm going to go down to the negative 2.5 and draw a perfectly horizontal line there. If I see an equation like number 6, I'm going to think of Vux. If my equation only has an x, then it's going to be a perfectly vertical line. So I'm going to go on the x-axis to the negative 4, and I'm going to draw a perfectly vertical line through that point. Now I know this is a bit of a long video for our first day, but I didn't want to rush through anything and confuse you. So I hope that this all makes sense, and I will see everybody in class tomorrow for some practice. Thank you so much for watching and taking notes, and I will see you then. Bye.